So,
Das wollen wir nicht machen.
die dritte Zahl, die relativ
So, okay. Ist er?
E-Mail
Leider nicht. Ja, E-Mail.
das Stockwerk, das du haben willst.
Das
sagt er, welchen du einsteigen gehst. Das sagt
right, then hello and welcome. Good evening to our .NET meetup in Vienna. This time already shortly before Christmas in person. Good evening to our .NET meetup in Vienna. This time already shortly before Christmas in person. Good evening to our .NET meetup in Vienna. This time already shortly before Christmas in person. Good evening to our .NET meetup in Vienna. Okay, short technical problems. That happens when you do audio checks. So, if you want to follow us, we are on YouTube as well as on Twitch. We do have a Twitter account and we have a community Slack. You can use this QR code to find all of the links mentioned. So, thanks for joining. And we also would like to thank our sponsors. So Keto Everett is hosting this today in person as well. And our sponsors are Rubicon and JetBrains. Some news from the community. If you want to stay up to date on everything .NET related, the .NET Foundation also has a virtual user group site where you can find a lot of the other meetings, meetups that are happening across the world. So if you want to join remotely, you can do it here. We also have some links to share from our recommended favorite .NET creators. So we can recommend Flashover's live stream every Saturday, 11 to 12 European time. We have Claudia Bernasconi, mentioned here, and Nick Chances. So, and without any further ado, I'd like to hand over to Stefan Koell with his presentation about the WinForms on ARM64.
Thank you very much. So hello, good evening, and thanks for joining me tonight. I'm going to talk about WinForms on ARM64 with .NET 7. Spoiler alert, it's the future here. So before we start, a little bit about myself. My name is Stefan Koell. I'm the co-founder and CEO of Koell Labs. We create a remote management solution on Windows and macOS, mobile, as well as a server product with a focus on managing remote systems. If you want to get in touch with me, here's my email address. Since everyone is leaving Twitter right now, I also have a Mastodon account. And if you want to see this presentation or information about our open source projects, you can visit my GitHub page as well. All right, I think before we start, let's talk about the app itself. I'm going to showcase here, let me just give you a quick glimpse what the application looks like. This is the screenshot of our previous version, of our current version. It's like typical WinForms application, but it has also, from the user look and feel, it's a crossover between Visual Studio and Office. So we have a ribbon, we have tabs, we have panels. You can create remote desktop connections, SSH connections. You can arrange panels. You can do file transfers. You can do VNC connections to Mac or Linux devices or Windows devices for that matter. So this is the Windows application. We also have the same application on the Mac, which is using the same file format, so you can open the same files and connect to the same machines. And we also have a mobile client where you can open the files. And the connection types we currently support can be found on the web page, a quite extensive list of connection types like remote desktop, terminal, VNC, web page connections for admin interfaces, external apps, PowerShell, and so on. So there's a lot of stuff going on. Just a quick glimpse what it's all about. So It's a WinForms app written in C#. In fact, it was the first C# project I've written in my life, at least the first version of this tool. It was a learning project, and it was written roughly 20 years ago. The first version, not this version, of course. So we also have quite extensive cross-platform code base, because we use the same file format on the Mac, for example, on mobile devices. And if someone of you remembers PCL, the portable class libraries, it was quite painful to get cross-platform code with complicated project structures and so on. So with multi-targeting on CS watch files, it's much easier, but we also have a couple of challenges because on the Mac we have to use Mono and cannot use .NET Core yet. So there is still a lot of pain with cross-platform code. RoyalTS has been around for a long time, but I always try to keep it up to date as good as possible. So I pushed myself and implemented stuff like dependency injection or messaging, in-app messaging using PubSub channels. HighDPI support was very tricky. WinForms is not really made for HighDPI support, but it's getting there. So .NET 8 will receive a couple of important updates. But since our UI is based on a DevExpress framework, a third-party vendor, they have pretty good HighDPI support already. Also, every icon you see in the user interface is using SVGs. There are no bitmaps, no PNGs. So that is very good for, if you have to use PNGs in HighDPI scenarios, you have to render 11, 12, 15 icons for each icon in the UI. We also have UI theming, but that's because DevExpress has very good support for UI theming. So we are always, leaning towards the Office UI styles. And we also try to keep up with the .NET framework. So when .NET frameworks are released, we try to get at least a beta version running on that framework. So you may ask, why WinForms in the first place? Who is still using WinForms? No WinForms? WPF maybe? WPF, okay. So, as mentioned before, one reason why WinForms, the first release was 20 years ago. And that was it. So if you wanted to write the Windows application, you had to use WinForms, or you had to use Win32 APIs, MFC apps, or VB6 was very popular back then. So WinForms was basically the only first-party UI API for user interfaces, and it was also a very thin wrapper around the Win32 API. So another reason why we are still sticking to WinForms is interop scenarios. So WPF has basic interop. You can host WinForms or ActiveX or the old components, UI components in a WPF application, but it's not as good as you might expect. There are a lot of issues you have to work around still, but rewriting everything from one UI framework to another is very expensive, of course. Another reason was the third-party ecosystem. So companies like Great City, DevExpress, ActivePro, they are investing a lot of time and effort providing very good WinForms component frameworks with a lot of good UI controls where you can rapidly develop applications. So that's a plus. You don't have to reinvent the wheel. And another reason why we still are on WinForms is nothing Microsoft released in the last 10 years is mature enough and has the required interop mechanisms to be interesting enough for us to switch to this framework. So you may think it's not so bad, just rewrite your app. We have a couple of features. For example, we have remote desktop connections in our app, and we are using the Microsoft RDP ActiveX control, which ships with Windows. And if you have to rewrite this component alone from scratch, it's not an easy task. There are open source projects like FreeRDP, which we already incorporated in our macOS clients. But as long as we can, prevent the situation so that we have to rewrite everything, we try to stay on a technology where we can use these components. Another issue is also we have a feature which is very popular. We actually allow you to start an external application and embed the main window of this application in a tab in our application. So we basically do a reparenting of the main window, which is not exactly supported by Microsoft, but it works. Mostly, you have a couple of side effects with focus handling and Windows messages weirdness, but it usually works very well. And we use this technology for third-party VNC clients like Ultra VNC or Type VNC. And we also use it to embed the PuTTY executable for SSH connections, for example. So we are looking at other technologies as well, but honestly, WPF, maybe Evonia, is one we can really seriously think about, because these are the only ones who have at least a minimum level of interop capabilities with the old technologies. Or maybe UWP, WinUI, maybe Microsoft is getting around and creating interop layers, but I doubt it, honestly. All right, next question you may ask, ARM64, why should I care even? So everyone has a phone, Samsung, iPhone, whatever, and the phone market in the last 10 years or so had great improvements and innovations around ARM64, because Intel, AMD, these CPUs were not really a good fit for mobile scenarios because of the power consumption, of the heat they produce, and battery life. And so they used ARM and ARM64 later on. And one specialty from the mobile market of ARM64 was the system on a chip, which is basically a lot of things you have on your motherboard in your typical Intel AMD machine, like hard disk controllers, display controllers, and stuff like that, are all incorporated in this single chip. And this makes it very fast, very efficient, and they made really good processors the last couple of years. So you have high performance, high efficiency, great battery life, all what is listed here. And I can speak from experience, this doesn't have a fan at all. And I can compile my application in a very short time. It is getting warm to the touch, maybe, so not really hot. Like my previous notebook was an Intel CPU, i9 with 64 gigabytes of RAM, and after an hour or so working on it, you almost burned your lap. So hot. So there is from Hector Martin, a Linux developer who is currently porting Linux to ARM64. He created a map of the Apple M1 Pro SoC and tried to figure out which areas have which components are available. So just to get a glimpse of what is, or even the memory, the RAM is on the chip in case of the M1 and M2. So we have now WinForms and we have ARM. So how can we make this work together? So the first thing is you need, of course, hardware. You need an ARM machine, which we're talking later about. Windows on ARM is not available as a you cannot download Windows on ARM from Microsoft and install it. There is no user image or anything like that. So it's kind of a special SKU which you only get if you are a Windows insider or if you have a hardware purchased from a vendor who is allowed to deploy Windows ARM on your machine. There are ways around it, of course. The internet is full of great ideas, so you can, of course, get Windows on ARM as an ISO image. The way I did it was basically using Parallels on the macOS system. When you install Parallels and start it up and you say you want to install Windows, it automatically downloads the ISO image, installs it, you enter your license key, and everything is just working. So one thing Windows on ARM has, what the other Windows does not have, is the Intel bridge, especially on Windows 11. It's a kind of an emulation layer where you can run x64 instructions, and it's quite laggy because the startup time is very slow, and also during operation of an application, it tends to be laggy. macOS has something similar because they switched recently also to ARM with the M1 and M2 chips. They have something called Rosetta or Rosetta 2, which operates a bit differently because the first startup, they transpile everything to ARM64 instructions, and they remember that, they cache that, and the next time you start it, it's much faster. I don't know why, but on Windows they seem to just do it in real time all the time, and it's slow, unfortunately. So let's talk about hardware a bit, because the hardware question is not as easy because there is not much available. You have a couple of Ultrabooks. The Surface Pro X from Microsoft was the first ARM-based Ultrabook based on the Snapdragon chip. The newly introduced Surface Pro 9 has an option where you can switch the Intel with an ARM CPU. Lenovo, HP, Acer, a couple of other vendors have Snapdragon ARM-based Ultrabooks where you can run Windows 11 for ARM. And there is this project Volterra, maybe you've heard of it. It's officially called Windows Dev Kit. This is the Windows Dev Kit. It's basically, it looks like a Mac Mini, and it's basically a Windows ARM hardware device where you can run and operate Windows 11 for ARM64 and run Visual Studio and develop applications for ARM64. Unlike the Apple Dev Kit, this is available to everyone, basically, so everyone can order this and use this, but unfortunately you cannot order it in Austria right now, so you have to go to the US, something like that. The interesting thing is, somebody on YouTube opened it up and looked inside, and it's basically a Surface Pro X with an additional daughter board for the additional connections. No display, of course, so it's nothing really fancy or new. There is another thing I've seen, I don't have any experience with that. It's called Ampere Ultra, which is a tower-based ARM workstation. And this looks very beefy, like 32, 64, 80 cores, and you can put a lot of memory in it. I have no idea if Windows on ARM runs on this. I guess it will, but I have no experience with this, and it's I don't know how much it is, but it's not as cheap as the dev kit or Mac Mini, for example. So there are a couple of hardware options, but it's quite limited, and at least, last but not least, there is another hardware option. You can buy one of the new Apple hardware devices like Mac Studio or an iMac based on M1 or a MacBook Air, like I have here, and run parallels. And especially if you are developing for mobile applications and desktop applications, this is the perfect machine because you have two worlds in one box. So the YouTube link I mentioned before, on this slide, this guy actually used a 2 or 3 year old Mac Mini M1 and compared it to the dev kit. Dev kit runs Windows 11 natively, and on the Mac Mini M1 you have parallels, and even in the parallels emulation, the Mac Mini, the 2-year-old or 3-year-old Mac Mini outperforms the dev kit by far in the single core and multi-core benchmarks. So this doesn't mean the dev kit is a slow horse. It does not. It's quite fast and snappy. A lot of users are very happy with the dev kit. But those two devices cost approximately the same price. So you get actually the faster machine, or maybe in a couple of months the M2, the even faster machine for the same price as the dev kit. So now we have a hardware, or I have the hardware. How about software? Of course, you need this special screw for Windows 11, which runs on ARM64-based machines. .NET 7 is available for Windows on ARM64. You can download it from the homepage, install it, no problem, works like a charm. The latest version of Visual Studio runs on ARM natively, which is awesome. And JetBrains Rider, the latest version also, VS Code, Edge, runs natively on ARM64. Google Chrome, not so much, still x64. And Google doesn't tell when they release an updated version. So if I open the task manager here, you see in this column here the architecture. And as you can see, Google Chrome is still x86, but everything else, except everything, runs on ARM64 natively. Here is the Edge, and here is Visual Studio, which runs natively, and somewhere is Rider, JetBrains Rider, ARM64. So this is a virtual machine on a Apple hardware. If you open up system information, you see something like this. Apple Silicon, 3.2 gigahertz, 6 processors, and I assigned 60 gigabyte of RAM for this machine. Hardware RAM is 24 gigabytes. So you have installed Visual Studio or JetBrains Rider, and you want to do .NET development for WinForms or WPF. So the very first problem is your solution, your projects, is this working on ARM64. So if you don't do any funny things with native code, invokes or something like that, it mostly will work just fine. So you open up your project and you set the runtime identifier to, I don't know, Windows 10 ARM64, and if this compiles, it's a good win. If it doesn't compile, it may be related to NuGet packages you have, because some NuGet packages may cause problems. If you have pure NuGet packages, like NuGet packages which are using just managed code and they are targeted to Net Standard 2, there should be no problem. If you have NuGet packages with native binaries included, you have to be careful because you need those native binaries compiled for ARM64. They won't run in your .NET process if they are not for the platform architecture. And I learned this the hard way because we have a NuGet package, our own NuGet package, which uses native code. And it's this component which actually embeds external applications in a WinForms application. So we recently created an open source package for that. And as I mentioned before, it uses reparenting Win32 APIs to do all this. You could do this all in managed code as well with p invokes. But in our case, we have two components. We have the .NET, the managed portion of this, and we also have an unmanaged portion, which is a C++ project. And this is the C++ project. What you have to do actually is you have to compile this code, because this is a native binary then in the end. You have to compile this for x64 and ARM64, and if you are still deploying to x86, you also have to compile it to x86. Once you have these binaries, you actually have then two DLLs. I created a DLL name with the architecture, with the platform in the name, so it's easier to see which DLL is in use. And what you have to do, there are a lot of things you can manage. You can create NuGet packages with you can create different NuGet packages. You can create a NuGet package for x64 and ARM64. We created a single NuGet package where we decide at runtime which native binary should be used. And one approach is you create an abstract class where you basically define your interface, the methods you want to platform invoke, and then you create for each platform, you create the methods and do a DLL import for the appropriate native binary. And there is one API which rules them all. So you just check the runtime information process architecture and use the one or the other API. You have to be careful in this case. Also, this took us a couple of hours. You need to make sure that when you pack this NuGet package, that you create the correct package path. Otherwise, your native binary will not end in the correct output directory when you compile that. So this took a couple of hours of trial and error, but in the end, it's also not very well documented, unfortunately. So if you have to do something like this, you can revisit the GitHub page and check it out. All right, so now we have everything in place so that we can compile an app for ARM64. So the first thing is what target architecture do I need? And you can use any CPU. Again, if you're not doing funny stuff with p invokes and native libraries, this will work perfectly fine, I guess. So if you have just simple business applications, data entry applications, I don't see any issue. And specialized targets may be necessary depending on your dependencies. So in our case, we have also a Chromium engine. Long before Microsoft released WebView 2, we have a third-party component called Essential Objects, which is basically a WinForms and WPF wrapper for Chromium. And this is native code. So even if you consume the NuGet package, you get native code because Chromium is native code. And usually you get x64. And they don't have an ARM64 component right now. And luckily for us, it's not a big issue because what they do is they start an external process and not in process the whole rendering engine and the whole workers. So in this case, let me just quickly start the app here. So here can you see you can see the app Royal.ts running natively on ARM64. And if I click on a web page view here, for example, you see other processes are spawned, and these processes are x64. But you can perfectly use this because the rendering is done in application with managed code, and the whole work, the Chromium engine runs out of process in a separate process. So this works just fine. And if you, for example, want to deploy your application for x86 as well, you may get a problem because if you target any CPU, you have to deploy 2 Chromium engines to your workstation, and one Chromium engine is roughly about 50 megabytes. So you have, instead of 50 megabytes deployment size, 100 megabyte deployment size. So for us, a couple of years back, we decided to drop the x86 support because our main customers are IT professionals and they tend to be on the latest hardware. So it was not a big deal for us to switch to x64 only and could get the deployment size down to only 50 megabytes more. Another thing we struggled in the past was having in the old .NET framework, having a Windows update destroy your application. So you have a .NET framework application targeted to 4.6 or 4.7 or whatever. A Windows update is deployed and your app doesn't run on that machine anymore. So I don't know if you had any experience with that, but we had a couple of incidents in this regard. So sometimes we were able to, tell the user just reinstall Windows, it will work after that, which was not very good for the customer. And sometimes it just, uninstalling or repairing the framework. There were tools you could download from Microsoft to repair the .NET framework on the system. It was messy. So we decided to make a self-contained deployment. So we actually deployed the .NET framework with our app. So we can ensure this app with this framework was tested and it will always work regardless if you update .NET 6 or 7 on your machine to a Windows update. Making 2 deployment artifacts also has a side effect on the CI/CD pipeline, so you have to build it twice, one for x64 and one for ARM64. And all the stuff we do in our CI/CD pipeline, like building, downloading the translation files, obfuscation, and everything, takes roughly 20 minutes for one architecture. So now we are 40 minutes. So if a third architecture is added, we need an hour to build the app. So On the good side note is that you can build an ARM64 artifact on an x64 SDK. So you don't need an ARM hardware to build your artifact. That's good news. You cannot run it on an x64 machine, but you can build it. Okay, so these are the last slides here. Some real-world performance. So I'm quite impressed with what ARM can do. You know, very low heat production, no fan noise. So before I got this little baby here, I used my laptop to compile my app, and you thought an airplane is taking off next to you. So it was really, really loud and hot. So this thing, compared to my old MacBook Pro, which was 3 years old, it was the highest end MacBook Pro you could get with the i9, 8 cores, 2.4 to 5 gigahertz, and it took 35 seconds to compile the app, to recompile everything in my app the second time. So after all NuGet packages, everything is restored so that I have a baseline. And on this lowest end MacBook Air you can get, it's 8 seconds faster. And the startup time is roughly the same. So this is quite impressive. After 3 years, you get a very low power, low end machine, which competes with the highest end machine about 3 years ago. And the first two columns, the comparison is also quite interesting because a year ago I created a Ryzen 9 machine with 16 cores for development specifically, and this was, you know, highest end a year ago. It did almost 5,000 euros or something like that, and it was really fast. But 6 months ago, I ordered the Mac Studio, the M1 Max with 10 cores, and it's not quite as fast as the 16-core Ryzen machine, but it's quite impressive. And again, no fan noise, no heat. That's the future. Well, if you have any questions, don't hesitate to talk to us. Here are my email address, Mastodon, and GitHub. And by the way, we are hiring, so if you are interested, we have a quite extensive and interesting technology stack. Yeah, thank you very much. Back to you.
Just wondering where the mic is.
No microphone.
Yes. Thank you very much, Stefan. Would you still stay in the hot seat for the top 10? So, do you have any questions? Then we do have a question from the chat.
Yeah.
So, do you know of any plans if there is Parallels or VMware Fusion running on Windows ARM with nested virtualization? So that, for example, with nested virtualization, we can run an Android emulator inside a Windows ARM that is running inside a Parallels of an Apple and one.
Sounds like Inception. I honestly don't know. I haven't tried it. I know that the Windows subsystem for Linux, which is also reliable on Hyper-V, I guess, this works. I can tell you that much. I don't know if the Android emulator will work, but yeah, we can find out.
If they are only interested in the Android emulator, I guess they want to develop for Android. This is not supported yet. The mobile workflows for the Visual Studio don't run on ARM64 yet. So Microsoft has to do something there. They are planning it, but it's not released yet. So you also cannot use a ARM chip for mobile development yet.
Too bad. But it's the future. Anything else?
So Jose says thank you. There are currently no more questions on the chat, so last chance to ask final questions.
Everyone is hungry.
Yes. Then then we get to a closing. Would you mind switching to the other slides, please? Thank you very much. So, okay, there we go. So, thank you very much, Stefan, for our final presentation of 2022.
My pleasure.
Thank you very much for joining as well with my presentation. We really appreciate it, being the final weeks of the year. Also, thank you very much for the viewers online. We appreciate it. Thank you to our sponsors, who support us financially and with tools that we can run these meetups. Thank you, Rubicon. Thank you, JetBrains, for powering us with licenses that we can give away, and also Tier2Every, who is also right now sponsoring the location and the pizza, which is about to come up for the in-person joiners. So this is the trade which is only reserved for in-person joiners, I'm afraid. If you would like to host a meetup, or if you know somebody who would like to host a meetup, so that we can have in 2023 also .NET related get-togethers, then let us know. We will bring the location and the content together. We currently have no fixed plans for our monthly meetups next year just yet. They are in the working. We will most likely switch to an alternating version. We will be doing remote, but also still have in-person sessions alternatively, so that we have both local speakers but also international speakers at our meetups. Please spread the word that we are hosting these meetups and the .NET Devs.at exists. Talk to your colleagues. This is, for me, this is how I got here actually. So spread the word, invite friends, potentially customers. There is always interested people with .NET, and spread the knowledge. You can tweet at us with @.NET-Devs.at and invite everyone. So here is a QR code to our links, to our social channels, to our YouTube and Twitch channels, Twitter profile, and the Slack channel. So if you have any questions, if you would like to follow up on a discussion, those are the places where you will find us. We also would love to hear your feedback. If you scan this QR code or follow the code down there, then please give us your feedback. What was good? What is the thing we should keep doing? What is your suggestions of improvement so that we can get better for the next year? And I just realized this is the final slide. So thank you very much for joining. This will be the end of our online stream, and here live we will continue with casual discussion and also some pizza. Thank you very much for joining, and see you 2023.
Danke, danke.